So let's just see what is mean, mode, median. Do you remember the numbers that we have talked about? One was the expectation, another is variance. I think these are the two numbers we have talked about, right? Expectation and variance. This mean is same as expectation. I mean the average number. Mode is basically the most frequent number that you can have. Median is the middle number. Let's just see that how to calculate these numbers. Before I go to calculate these numbers, tell me, can you calculate the expectation? Can you calculate the variance? How to calculate the expectation? I think you know, which is basically using the formula, which is, I mean, depends on the random variable, whether it is discrete or continuous. But for now, let's just see that this is the discrete random variable. And for the variance, I think you can do it, right? Expectation of x square minus expectation, or maybe let me write another formula. What was that formula? Expectation of x minus expectation of x. Do you remember there were two formulas? And this formula is actually the main formula. And then we simplified that to another formula, which was coming out to be expectation of x square minus expectation of x whole square. Okay. So you can calculate this expectation and variance. Now, suppose instead of giving you probabilities, if I give you the data, okay, it is basically after the probabilities. If I give you the probability, given probabilities. Suppose if data is given to you, given data, then can you calculate the expectation? I think we can calculate. How? We can just take the average. Okay. So if data is given to you, then we cannot do anything. We can just take the average. And do average consider the probabilities? Yes, basically from the average, you are actually considering, you are actually finding out the probability, and then you are finding out the expectation. So it is just an average. Maybe x1 plus x2 plus x3 plus xn upon n. I mean, given the data, you can find out the average, and this is just expectation. Okay. Now, given the data, can you find out the variance? If as probabilities and these things are not given, then maybe you can say that x minus this average that you have, whatever you average you have, and this whole square. Okay, so this is x1 plus similarly x2, whatever the second point you have, x2 minus average whole square, right? Average whole square like this. Okay, let me do it clearly. So given the data, also we can calculate these numbers, and given the probability distributions, also we can calculate these numbers. So these numbers are basically looking like this: xi minus average whole square, and since this is average, so again summation. Right? Everyone is comfortable with these four things. I mean, given the data, given the probability distribution, how to calculate these two numbers: expectation and variance. Okay, I think this is easy. Like you just need to take the average and subtract. I mean, take the distance from the for the every point from the mean, and then take the square, take the square, and then take the average out of all. Okay. Now let's just see that how to calculate these numbers, which are mean, mode, median. I think mean is just an expectation, that is okay. So let's just see how to calculate this mode and median. Now, again, first we are going to see that how to calculate this mode and median using the data. I mean, if data is given to us, and then we will see how to calculate this mode and median using the probability distribution. Let's just see using the data. So mode is one number, again, to remind you, which is the most frequent number in the data. And median is the middle number. Let's just see that what does this mean. If I say you that find the median of this data, median means middle number. First you sort this, which is 0, 1, 2, 4, 5, and then tell me the middle number, which is 2. So you will say median is 2. So given the data, it is very easy, right? Median is 2. Now, median of this data, you will just sort it, maybe 10, 20, 40, 50, and then you will say that, okay, if in between, if there are two numbers, then you will just take the average of these two numbers. 20 plus 40 by 2, it is 60 by 2, 30. Okay, median is 30. Okay. Now, given the data, I think it is very easy. You just sort it out and then take the middle value. If in the middle there are two values, just take the average. Okay. Let's just find out the mode of this data. Mode is the most frequent number that is coming out to be. Then what do you think? What is the mode of this data? This is coming out 3 times. This is coming out 4 times. This is coming out 4 times. This is coming out 1 time. Then what is the mode of this number? This is 1, 2, 3, 4. Yes, that is correct. Mode is basically 1 and 2 both, because 1 and 2 both are coming out to be equal number of times. So you will say mode of this number, this data is 1 and 2. Okay. Whatever is coming out to be most frequent time, this is mode. If there are multiple numbers, you will say there are multiple modes. So given the data, I hope you can calculate this mode and median. Okay, mean is just an expectation that we already know. You remember the difference between the expectation and the average? What is the difference? Actually, there is no difference if the data is huge. So expectation is also an average, right? And like we need to add just one more line. I mean, saying that expectation is an average is not 100% correct. Expectation is an average. It's not 100% correct. Like we can just add one more line to make it more correct. What we can add? Just one more, just two more words. What are those two more words? Expectation and average on large data. Yes, on large run or large data, whatever. I mean, whenever they say expectation, just treat it as as in just an average. If the data is huge, then both are same. Okay. Okay, you were just saying these are the three numbers. Actually, it's on. Okay. You, if you want to call this as a word, these are the three words. You want to call this a word, so that's okay. I was just thinking about the large run. Okay. So anyway, I hope that you know that what is like how to calculate this mean. But now we are going to see that how to calculate the mode and median using the using, let's suppose they give you the probability distribution. Suppose they give you some probability distribution, then you know that how to calculate this mean. At least the mean is clear to everyone, which is this one. Just 1 second. Right. So mean is clear to everyone, which is this one, which means to calculate the mean, I will calculate the expectation. If it is discrete, then I will do like this. If it is continuous, then I will do like this. Okay. Now, suppose you want to calculate the median. If you want to calculate the median, then what we will be doing, given the probability distribution, it is actually very tricky. It says that mx is defined to be median if the probability of x, like probability of random variable x is less than or equal to mx is greater than or equal to 1 by 2. Okay, and the probability of x greater than or equal to mx is greater than or equal to 1 by 2 for discrete random variable. What does this mean? Let's just try to understand this. So suppose mx is some value which is satisfying this thing. Then we call, if mx satisfies this thing, given the probability distribution, given probability distribution, if mx satisfies this property, then we call it median. And what does this property says? See, it is saying that mx is being less than or equal to 1 by 2. Sorry, this x is being less than or equal to mx. This probability is greater than or equal to 1 by 2. What does this mean? It means that random variable is basically, let's suppose that these are the different values that you have. Now, let's suppose that this is mx. This is mx. Now, the values of x that x can take less than or equal to mx, which means in this area, the values that that the random variable x can take, including this mx, is the half probability, or maybe greater than a half probability, greater than or equal to half probability, which means half of the points must be in this. See what I'm trying to do here. Let's suppose that I am given a probability distribution and I try to draw a sample. Okay, if I draw the samples, then the samples should follow this kind of thing, which means wherever this mx I have drawn, and then if I draw many samples, then half of the samples should be from this area, and half of the samples should be from this area, which means that the probability that x will be here is greater than or equal to 1 by 2. The probability that x is here is also greater than or equal to 1 by 2. How can both the probabilities greater than or equal to 1 by 2? Okay, the thing is that this median could be spread over multiple points. I mean, there could be multiple medians. I mean, the data, I will just tell you, not multiple medians. Basically, there are multiple points which are having the same value as median. So let's just understand with the example. Okay, and then we will probably come back to this definition again. So let's first understand with the example, and let's just take this example. Suppose that they have given you this random variable x, then they are saying a discrete random variable x can take on the values which are 2, 3, 4, 5, 6. And this is the probability distribution that they have given. Now what they're saying, construct the probability distribution table for x, find the mode, find the median. I mean, they are saying first, this means just like find the PMF and find out the mode and find out the median. Let's just do it. Okay. So, and then you will get to understand what I'm trying to explain you. So suppose that this is given to you. Let's just maybe find out the PMF. I mean, now let's just write down the PMF. So for the different values of x can take different values, which are 2, 3, 4, 5, and 6. And then this probability distribution is saying that x being 2 is 4 upon 90 probability. This being 3 is 9 upon 90 probability. This is 16 upon 90 probability. This is 25 upon 90 probability. This is 36 upon 90 probability. Okay. And I mean, this is the probability distribution that you have. Okay. Let's just find out the mean and mode. Sorry, not mean. I mean, mean you can find out. That's not a problem. But let's just find out the mode and median using this probability distribution that they have given to us. So using the data, are you comfortable using the data? How to find out the mean and mode, mean, mode, median, anything? Using the data, I think you are comfortable, right? Now let's just do it using a probability distribution. How to find out? The thing is that we are not going to apply any of this formula. I mean, there are formulas to apply. I mean, if you want to find out the mean, then median, then this is the formula. If you want to find out the mode, then there is a formula that is saying that probability of x mode is an overall maximum, something like that. Okay. But we are not going to use those formulas. I can verify using those formulas, but we are not going to use those formulas to get the answer. But once we get the answer, we can verify the answer using the formulas. Let's just do it in that way. We will find out the answers without using those formulas, but just for our satisfaction, once we get the answer, we can verify whether the formulas are working on the given answer or not. Okay, let's just do it in that way. So what we are going to do, given this probability distribution, can you just draw the samples from this probability distribution? Let's just try to draw the samples. Suppose you draw maybe 90 samples you draw. Okay, which means that there will be 2, there will be some 4, some 3s, there will be some 4, there will be some 5, there will be some 6. Right? If you draw the 90 samples, let's suppose that this 2 is coming maybe 10 times out of 90. How many is remaining? 80 is remaining. Maybe let's suppose 3 is coming maybe just out of 80. Maybe let's suppose it is coming let's suppose 30 times. Then how many remaining? 30 plus 10, 40. 50 is remaining, right? Then let's suppose this is coming 20 times, then 30 is remaining. Let's suppose this is 10, this is 20. Okay. Suppose, which means if I draw some data for using some samples from this probability distribution, suppose this is what I'm getting, which means 2 is appearing 10 times, 3 is appearing 30 times, 4 is appearing 20 times, 5 is appearing 10 times, and 6 is appearing 20 times. Let me know if this is okay to everyone. Is this, first of all, is this possible to get this data from this probability distribution? Yes, this is very much possible. But actually, this is not a good sample that justifies the probability distribution, which means if I just hide you for a moment, I just hide you this information from you, okay? And I just give you the data. And I ask you the question that what could have been the probability distribution? Then what you will say? You will say the probability distribution could have been, I mean, if I just hide you this particular thing, just one second. Let me go to the next page so that it is okay. Okay. So suppose that if I just hide you this particular thing for a moment, and I do not tell you the underlying probability distribution, I just give you these samples. I just ask you that what could have been the probability distribution that led to this particular data. Then you will say that most probably that x being 2, the probability is 10 upon 90, right? X being 3 is the probability, the 30 upon 90. I mean, what I'm doing, these are not real probabilities. These are sample probabilities, basically. I mean, given some small sample, I'm just finding out the probability. If I give you the huge sample, then probably you can get closer to the real probabilities. These are the real probabilities, right? These are the real probabilities. And I mean, people call it population probability, real probability, something like that. But these are called sample probabilities. Okay, these are sample probabilities, and given this sample, if I just ask you that what could have been the real probabilities, you might approximate like this. There is no magical power that you can get these real probabilities. But from this data, you can say that most probably this could have been the probabilities. That the probability of x being 4 is 9, 20 upon 90. Probability of x being 5 is 10 upon 90, like this, right? You can easily get the probabilities from the data. But is this real probability? I think 4 upon 90, this is just 1 upon 10 upon 90, this is 30 upon 90. This is not a good match, right? I mean, this is okay that you can get this kind of probabilities, this kind of data. First of all, let's suppose that I do not know the underlying probability distribution. So you can get the samples, this kind of sample, that is okay. But from this kind of sample, if you find out the probabilities, then this will be not the same probabilities. That is okay. I mean, this was just some 90 samples. Maybe in the 90 samples it is not justifiable. Let's suppose if I draw maybe 10,000 samples, then probably I will get closer to the real probabilities, right? Maybe if not 10,000, maybe 1 million. If not 1 million, then maybe 1 billion, right? 1 trillion. Which means like if I have a good amount of data, then probably these sample probabilities will approach to my real probabilities. But let's not worry about it. I mean to say that yes, this kind of samples are possible, but the problem with this sample is that it is not a good justification of my probabilities, right? Actually, what I want to do, I want to forget about the probabilities, which means given these probabilities, I just want to forget about the probabilities. I want to work with the samples. So let's have a sample which is the very good justification of my probability, because I'm just doing a jugaad. Okay, this is a pure jugaad, which means I was expected to work with the probabilities, to be very honest, but I am not much comfortable to work with these formulas. Okay, so these formulas, let's suppose I'm not much comfortable to work with, so I'm just doing a jugaad. What is the jugaad? I'm just drawing the samples. ठीक है, अगर जुगाड़ लगा ही रहे हैं तो थोड़ा अच्छे से लगाते हैं, which means let's have some numbers which is better justification of my probabilities, so that I can forget about these probabilities and I can say okay, these are my sample points. ठीक है, so I will fake my samples in a perfect way. I mean, एकदम आइडियल सैंपल्स लेते हैं, ठीक है, 90 samples, we will draw the 90 samples and we will say that this is the 90 samples we are getting. So now can you tell me what could have been the perfect jugaad? See, instead of this, let's just have the perfect jugaad, which means I want to forget about the probabilities. So that's why I want to have some good numbers here. Maybe if I'm drawing the 90 times, you can say it is 4, it is 9, it is 16, it is 25, it is 36, which means 2 is coming 4 times, 3 is coming 9 times, 4 is coming 16 times, 5 is coming 25 times, and 6 is coming 36 times. Okay, this is actually the perfect jugaad. You can say it is a perfect one. So now I will forget about these probabilities. I will say that let me work with the data, because this data I have just faked it so perfectly that it looks like the real probabilities. I mean, these are the actually real probabilities. So let's just work with this data. Is everyone okay till this point? See, I was expected to work with the probabilities, but I will not do that much calculation. I will work with the normal data. ठीक है? तो पहले एक बार data sample कर लेते हैं और data perfect data sample करेंगे. Now let's just find out the median, which means if 2 is coming 4 times, 2, 2, 2, 2. Now 3 is coming 9 times, 3, 3, 3, 3, 4, 5, 6, 7, 8, 9. Okay, 4 is coming 16 times, like this. So can you tell me the middle point? Can anyone tell me the middle point? Such that the half of the numbers are here and half of the numbers are here. I think, see, this is 9 plus 4, 13. And 13 cannot be 4 cannot be the middle point, I think. This is 13 plus 16 is 29. Sorry, 13 plus 16 is 29. So till this point, now here there are many 5s. Before this 5 there are 29 points, and let's suppose after this 5 there are 36 points. नहीं, ये तो इतना अच्छा नहीं है 5. ये वाला 5 अच्छा नहीं है क्योंकि before this 5 there are 29, and I think some middle 5 maybe, right? Maybe you can say that this is 36 and how many? This is 25, right? तो कौन सा वाला 5 लेना चाहिए? Maybe you can have a 5. ठीक है, कोई फर्क नहीं पड़ता, मतलब बेसिकली इस बीच में से एक 5 होगा. Is everyone agreeing with me that one of the 5 will be there? Maybe this one, right? Maybe this one, because 6 cannot be the median, because 6 से पहले there are like this is 36 numbers and these are more than 36 numbers. So this is one of the 5, 16 5. Okay, So 16th 5 will be there. Okay, it's not a great mathematics to calculate that which one 5 will be there. So you can say the median is 5. How we have calculated? Using the data. We will not do using the probability distributions. Okay. Now let's just see if it is matching with my formula. What was the formula? I mean, just to be, make sure that it is actually correct. You do not need to cross check in the examination, but just for sake of doing it, let me just do it. Basically, the formula says that probability that x, the x being less than this median is greater than or equal to 1 by 2, and probability that x being greater than median is also greater than or equal to 1 by 2. Let's just see if this is true. Probability of x being less than 5. Let's just check this. Probability of x being greater than 5. Right? So let me just show you the formula. Sorry, this is x less than or equal to, yeah, sorry, this 5 should be included. This x less than or equal to here, and then greater than or equal to here. Can you calculate these probabilities? I think we can easily calculate. This is what we know, and then we want to calculate these probabilities. Let's just calculate it. X less than or equal to 5 matlab you will add all of these numbers. Just add all of these numbers. This is 4 plus 9 plus 16 plus 25 upon 90. And x greater than or equal to 5 matlab you will add all of these numbers, 25 plus 36 upon 90. Let's just check whether both of the numbers are greater than or equal to 1 by 2 or not. I hope you can easily check. This is 25 plus this is 9 plus 16 is again 25, and then 50, and this is 54, which is greater than 45. Basically, this number is greater than or equal to 1 by 2, right? You can easily check this number is greater than or equal to 1 by 2. So that's why this number is greater than or equal to 1 by 2. Okay. And similarly, this is 61 upon 90. So that is why this is also greater than or equal to 1 by 2. That's why this is greater than or equal to 1 by 2. I mean, you can verify, but we do not need to verify. Okay. So what we will do, we will just fake the data. We will get the samples, the perfect sample that we can get, and then we will calculate the median. Okay. So that's how we will be solving the question. Instead of solving the question using this formula, it will be tricky actually. If you solve the questions using the formula directly, you might get confused. So the perfect way to do is like this. Now, let's just find out the mod. Now, can you find out the mod? Given this perfect data, can you find out the mod which is coming most number of times? Can you tell me which is the number which is having the most number of times? Obviously, it is 6, right? So you can say, let me write here only, mod is 6. Let's just see with the formula. Actually, formula is very easy for the mod. It is only the median which is tricky. Mod is saying that for the mod, they are saying that mod is any point for which probability of being that point is maximum. So you from this this PMF only you can say mod is 6, right? Because they are saying the probability of being that mod is overall maximum. Okay. And in case of continuous, instead of PMF, it will be CDF. So anyway, like that's all we need to know for this mean, mode, median. Mean, you know how to calculate. Mean, and then mod is just a most frequent number, and what was the other number? Median. Yeah, median is just a middle number. Given the data, we can do it. Given the probability distribution, we will just fake it and then we will do it. Okay. I hope that is easy. Now, maybe for the continuous case, if they ask you to find out the median, actually they will not do it. But can we draw the samples? I don't think it is easy to draw the samples in case of continuous. But it is easy. For the formula is actually easy. For the continuous, the formula itself is easy. Right? They are saying it is just one number for which the CDF. This is CDF. Right? Do you remember the CDF? There was a PDF. There were 3 terms: PDF, PMF, and one is CDF. Tell me, PDF is for continuous or discrete? It is for continuous. PMF is for continuous or discrete? It is for discrete. CDF is for continuous or discrete? Yes, it is for both continuous and discrete. Okay. So this formula is actually easy. If they ask you the median for the continuous case, then you can find out the median like this. What does this say? Let's just try to understand this intuitively. What does this formula says? Maybe let me copy it to the next page. So this is median, and I hope median for the discrete is okay to everyone. Let's just see that what does this median for the continuous, what does this say? It says the probability, if you, let's suppose there is some CDF, okay, I mean CDF could be anything, sorry, not CDF, PDF. Let's suppose there is some PDF of the continuous, it could be normal distribution or some other distribution. What they're saying that median is some point for which you will say that, let's suppose this, if I call this is median, then you will say that there are half number of points, x is less than or equal to median, there are half number of points, I mean if you draw the samples, there are half number of points which will be coming less than or equal to this particular data, okay, this particular median. So which means in case of normal distribution, can you tell me the median? See, this is actually very symmetric about the mean. So if mean is mu, in case of normal distribution, median is also mu. In fact, for the normal distribution, mean mod, because this is highest, right? Do you remember the definition of mod? This PDF should be highest. Since at the mu the PDF is highest, so that's why it is mod. And this is also the median. Median means that it is at middle. I mean, there are half number of people that are lying here. Okay. If you calculate the area of this, the whole area is one, but this area is 1/2. And this area is also 1/2. So it is satisfying this property. Actually, both all are same for the normal distribution. Okay. Anyway, like you do not need to know these things to that much extent. If you can, like at max, they will ask you using the discrete values, then you can just draw the samples, you can do it. If they ask you, even if they ask you using the continuous values, then in the continuous, actually it is easy, it's not tough. It's just saying that the CDF, which is fx, and then if you put the median here, then it should be 1/2. Okay. Now let's solve one question. Here, this question has been asked in GATE 2017. They are saying that x is a Gaussian random variable. Okay, Gaussian and normal both are same actually. Okay. Gaussian is just one more popular name. Gaussian random variable with mean 0 and variance sigma square. Okay, mean is 0. X is something like this, where mean is 0, and there is some variance which is sigma square. Okay. Y is another random variable which is taking the max of x, 0, where max of a, b is maximum of a, b. They are asking median of y. So this is x. Can you draw y? Y will be maximum of 0, x. So if you take maximum of these values, then it will be just 0. I mean, these values these are the negative values, right? -5 or something. If you take a maximum of any, I mean, x could be anything from -infinity to +infinity. X could be anything, including the 0 like this, right? X could be anything. But if you take these values from the x, and then if you take the maximum with the 0, then it will be 0 only. So basically, y cannot be negative, because if x is negative, then y is not negative. You're getting my point? See, if x is negative, x could be anything from -infinity to 0. For all of these values, y just 0, And if x is positive, which means maybe greater than 0 or 0 to infinity, then what is y? Y just x, which means y PDF will look like this. Anyway, like it cannot take these values, so it will look like this. That it is 0, it cannot take the negative values, and this PDF is same. This PDF is same like this. Basically, y PDF will look like this. Right? Okay. Now, what they're asking is median of y. I think it is easy. See, can you tell me the median of x at least? It is 0, right? 0. Now, what I did, I just compacted half of these values. See, the half of these values in just one value 0. In just one value 0. Which means I just compacted all of these values in just one value 0. Now, which means that that for every x, see, let me just write like this, that x may take any values from -infinity to maybe 0 to infinity. With what probability that x is taking these many values? probability that x is less than or equal to 0? Can anyone tell me? And probability of x greater than or equal to 0? This is 1 by 2. This is also 1 by 2, right? Now, whenever x is less than or equal to 0, can you tell me what is y? Probability of y being 0, isn't it same as probability of x less than or equal to 0? Because whenever x less than or equal to 0, y is actually 0. That means it is also 1 by 2. Right? Now, tell me what is the probability that maybe you can write y less than or equal to 0. Also, it is fine, right? I mean, actually, y cannot be 0. That's why it is. I can write y less than or equal to 0. I mean, just for the sake of writing, I'm writing it. Okay. So y less than or equal to 0, because y cannot be actually less than 0. Because if I say y less than or equal to 0, it means that y equal to 0, right? For the sake of writing, I'm writing it. Now, tell me what is the probability that y greater than or equal to 0? When can y greater than or equal to 0? Whenever x is greater than or equal to 0, isn't it? I mean, whenever x is greater than or equal to 0, y is already greater than or equal to 0. And then what is this? This is 1 by 2. So probability of y less than or equal to 0 is also 1 by 2. Probability of y greater than or equal to 0 is also 1 by 2. Probability of y less than or equal to 0 is 1 by 2. Probability of y greater than or equal to 0 is also 1 by 2. Isn't it satisfying the median formula, which means probability of y greater than or equal to that median, whatever is this median, it should be greater than or equal to 1 by 2. Probability of y less than or equal to whatever is the median should be greater than or equal to 1 by 2. Isn't it saying that median is 0? Because is it saying greater than or equal to 1 by 2? It is, you are getting 1 by 2, that is fine, right? So you can say median is 0. How you are saying it? Because there are half of the numbers which will be less than or equal to 0 for the y, or in fact, like half of the y will be just 0. Okay. I mean, the half, if you draw the sample, like you will be getting many zeros. You will be getting many zeros, and you will be getting half of the numbers greater than 0 actually. So from this, you can say, even from the formula, you can say that half of the numbers like you are getting that are basically are less than or equal to 0, and half of the numbers are greater than or equal to 0. And the formula says that there should be the probability which is greater than or equal to half, which means there are many points like x lie in this area is the greater than or equal to half probability. See, let's just understand like this. See, probability for the median definition, I'm saying greater than or equal to mx is greater than or equal to half. What does this mean? It means there is a median is such a point such that x being in this area, half of the point should be in this area, right? So let's just for the sake of explanation, I will modify it for the sake of explanation. Let's just write like this, equal to 1 by 2. So they are saying half of the points should be here. Is this okay to everyone? That x greater than or equal to mx and x less than or equal to mx, which means mx is such a point, or median, let me just say median m is such a point where the probability that any number greater than or equal to 1, there are half numbers here and there are half numbers here, which means if you draw the samples from this kind of probability distribution, you will be getting half numbers here, you will be getting half numbers here. But the problem with this exact equal to is that, can anyone guess the problem with the exact equal to? Is that basically median are multiple. Medians itself could be in this area, right? Median itself could be in this area. Median itself could be in this area. That's the problem. Which means, like, I do not want to go to much detail, but if you're just writing median m, then someone will argue that, see, your m is this, and the m, like if you talk about m less than or equal to m, then there are not just exact equal to 1 by 2. It is actually greater than or equal to 1 by 2. Someone will argue something like this. I mean, basically, there could be multiple medians. If this is just one median, then I think it should be just 1 by 2. But if there are multiple medians, which means that there could be multiple medians which are possible, then it will be greater than or equal to 1 by 2. And this will also be greater than or equal to 1 by 2. So you can say that more than half of the numbers are here and more than half of the numbers are here. If more than half of the numbers and more than half of the numbers are here, then is this possible that if there are 100 numbers, then is this possible that 60 numbers are here, 60 numbers are here? Obviously not possible. Some of the numbers are common. And what are those numbers? Those are actually medians, which are common. Anyway, like, you do not need that much explanation. That's why I'm keeping myself to very restricted. You just need to know For this particular question, you just need to solve this question using the formula, which is basically like this, that by less than equal to 0 and by greater than equal to 0 should be greater than equal to 1 by 2. I mean, by less than equal to median and by greater than equal to median, both should be greater than equal to 1 by 2. And in fact, for 0, it is true. How we have calculated it? Using our intuitive idea that y less than equal to 0, which means if I want to calculate y less than equal to 0, you will say it is same as y equal to 0, and y will be 0 whenever x is less than equal to 0. And which is 1 by 2 because it is a symmetric distribution. I mean, it is a normal distribution about the 0. So, and y greater than equal to 0, it is possible only when x greater than equal to 0. This is also 1 by 2. That is why 0 is median. Okay. Okay. So we have covered all of these numbers, which are mean, mode, median, and these are the formal definition. But we generally do not need formal definitions. We will just draw the samples. Okay. So they have not asked any question till now. I think from this, I think they have just asked this question, and even at that time, it was not even mentioned that it is like mean, mode, and median in the syllabus. At that time, they have asked. In 2017, it was not mentioned that it is in the syllabus. I think in 2020 only they have added. If I'm correct, I think I'm right. Okay.